A little bit about coding up a regular function. Now, the book doesn't do such a good job with this, so I'll go slowly here. We always start with our output. And I'm going to try to first write a function that squares a double. So when you square a double, the output is a double. You start with the output, you name your function. In this case, I'm going to call it square, and then you indicate the parameters. In this case, the input is going to be a double, and I'm just going to name the double arg, for argument, short for argument. Now within the braces, we write the code that is associated with this function. Okay, now what is this function going to do? It's just going to square the argument here and return it. Okay, it's going to be a double. So one line of code, return, and I'm just going to do the math inside the return function here. So just arg times arg. Alright, and that's it. One line of code. Usually functions are very specific. Try not to do too much within any particular function. So this is a squaring function. It takes in a double and it returns that value times itself. Okay, now how do you use the function that we just made within the main function? Well, just like in math. Let me show you. Within the cout and the output stream, we make a function call, square, and send it a number, so 2.1 say. And then we'll end line. So within the output stream, we're sending 2.1 to the square function, and so locally arg is getting replaced with 2.1, and then it should be returning 2.1 times 2.1, which is a double set in the output stream. Let's see if it works as expected. No errors, that's good. And when I run this, sure enough, there's the 4.41. Okay, that's great. Certainly you don't have to hard code the numbers. You can prompt the user or even initialize a double here, say x. Let's use 4.3 this time. Instead of 2.1, we'll make the function call and send it x. Okay, we'll test that, show that it works, and sure enough, 18.49 looks good. Okay, so that's the basics for a regular C-type function. This has been around for a long time. Now the book talks about member functions within a class. Okay, I think it's important to know how functions are written in C, just like this. Now, one final tidbit. The next thing we want to do is separate our implementation here for this function from the design. So what I'm going to do is cut and paste that to the bottom. Now usually we want to separate our implementation here, so I'm going to name this as function implementation from our design. So the design for this function is a double. Okay, it's a square, and the input here is a double. That's it. What I just wrote here is what's called a function prototype. And it describes how the function works. Right? The parameter here is a double. All right, so that's the input, and the output is a double. And then the actual code for the function is down here somewhere else, usually in a different file. But in this case, I put it below the main. Now when you build that, hopefully, it should run just as expected. Okay, so that's the beginnings of separation. You hear a lot of us talk about header files. You know, header files contain nothing but function prototypes, and the function prototypes tell you how the function actually works. In fact, you don't even need to put in the name of the parameter here. Okay, you can even get rid of that and it should still work. Sure enough, there it is. Okay, so a function prototype, again, just tells you how the function works, shows you the input and the output, and then you can use it within your main program. Okay, so that's the beginnings of separation, and that's just a regular simple C-type function.